Good morning. Welcome to Currents Chem World. In this video, we will study what is Wilkinson catalyst. It is used for hydrogenation of alkene. Wilkinson catalyst is a homogeneous catalyst used for hydrogenation of alkene. Okay, how it is prepared? Wilkinson catalyst. This is the rhodium monochloro triphenyl phosphine complex. This is a square planar complex. This is called Wilkinson catalyst. This is prepared by refluxing, by heating rhodium chloride and triphenyl phosphine in ethanol. Okay, and in this case rhodium is in +3 state. In the product it is in +1 state. How it is possible? It is possible because one equivalent of triphenyl phosphine, phosphorus in one of which is oxidized to +3 to +5. Therefore, rhodium is reduced to rhodium 1. It is a 16 electron square planar complex. Here pH refers to phenyl C6H5. It is a D square planar complex, DsP2 hybridization. This is the 3D structure of Wilkinson catalyst. Okay, it is called a homogeneous catalyst because the catalyst and the reactants are in liquid phase. L equal to, in this case, L is nothing but triphenyl phosphine. S refers to solvent. Okay, this is iridium analog. They are both in the same group, but iridium analog is not a catalyst because iridium triphenyl phosphine bond is so strong, whereas rhodium triphenyl phosphine bond is labile. Okay, it can be dissociated. The ligand can be dissociated. We will see the mechanism. Okay, let us now study the mechanism of hydrogenation of alkene using Wilkinson catalyst. Okay, so let us take Wilkinson catalyst, and in the first step oxidative addition takes place. Okay, the oxidation state of rhodium is +1 here. In this state +3, so it forms hydride. Okay, oxidative addition compound. This is square planar complex, and this is octahedral complex, and this is 16 electron species, this is 18 electron species. Okay, so next step is ligand dissociation. One of the triphenyl phosphine is dissociated so that alkene can bind. Okay, so that alkene can come and bind. Okay, now what happens? One of the ligand is dissociated and it is replaced by solvent molecule which is loosely bound. It is loosely bound so that alkene can come and bind. This process is called ligand dissociation and solvent association. Okay, now the solvent is replaced by alkene to form pi complex. You see here. Okay, and I have moved hydrogen from here to here. Okay, so this is called bicomplex formation with the alkene. Next step is very important. This is the rate determining step 1,2 insertion. What is 1,2 insertion reaction? Okay, and you see this is bicomplex. Now this carbon is bonded to this carbon, N carbon is bonded to rhodium, see here, N carbon, and hydrogen migrates to here, and hydrogen migrates here. Okay, hydrogen migrates, that is 1,2 insertion reaction. Okay, and this reaction is the rate determining step. And in the next step, what happens is alkane, the product is released. Okay, so it undergoes reductive elimination. It undergoes reductive elimination and also ligand association. Okay, thus the rhodium Wilkinson catalyst is regenerated at the end of the reaction. Okay, there is another route we will explain now. It was asked in CSIR. Okay, I am showing the oxidation state. Okay, now it can also go in this route to this stage. Okay, how? See, in the first step, it undergoes ligand dissociation. See here, ligand dissociation. One of the ligand is replaced by solvent, loosely bound solvent molecule, and then it undergoes oxidative addition to reach this step. Okay, so there are two routes I can follow. So this is the complete cycle of Wilkinson catalyst. So the mechanism involves the following reaction steps. What are the various reaction steps involved in Wilkinson catalyst? Hydrogenation of alkene, oxidative addition, we have already seen. Rhodium 1 is oxidized to rhodium 3 followed by hydrogen molecule addition. Ligand dissociation. The complex, the rhodium complex is labile, so it loses its one of ligand, so that solvent molecules alkene can bind. The vacant site is loosely occupied by solvent molecules. And bicomplexation, alkene binds in the solvent molecule site and forms pi complex at the solvent site. Then once 1,2 insertion, alkene formed bicomplex, alkene bond end on to rhodium. One end of carbon is covalently bonded to rhodium, and hydrogen atom insertion occurs through 1,2 migration as explained in previous slide. Reductive elimination, it is a reverse process of oxidative addition. The catalyst is generated in this step. Okay, what are the key points to remember for competitive exam? Less hindered alkene undergo faster hydrogenation reaction. Cis addition takes place. Second, cis addition takes place. 3. Rate determining step is the 1,2 insertion reaction because bond is formed. Okay, two bonds, covalent bonds are formed. And iridium analog does not show catalytic activity because of its inability to undergo ligand dissociation, because iridium ligand bond is very strong. Thank you for watching. Please share and subscribe. Thank you again.